what was that point? 1, 1, right? So we know that dy dx at the point 1, 1 is going to be equal to 1 squared times 1 minus 1, which is what? 0. How are we going to notarize, those of you that have done this before? Oh, what is that? That's a what kind of line? Horizontal line. Why do you write a horizontal line here? Because it has a slope of 0. So at that point, it has a slope of 0, so we're going to draw a line segment with a slope of 0. So what about that point right there? What is that one? 1, comma 2. What's dy dx at 1, comma 2? It's going to be 1 squared times 2 minus 1 is 2. So what do you draw there? A line segment with slope of. And are you being totally exact here? Do you sit there and you measure out to like extreme decimal accuracy? No. You do a slope of 2, so maybe something like. Oh, wait. I'm sorry. You're absolutely right. I was like, huh, okay, that seemed wrong. A slope of 1. So again, are we looking for better than that math? Yes. A slope of 1. So roughly like this. And then what about right here? What point is that? 1, 3. So you're looking for dy dx at the point 1, 3. So that's going to be 1 squared times 3 minus 1. What is that equal to? That's 2. So what do you draw here? Steeper than the last one. Exactly. What you're getting is a slope field. A direction field is sometimes what it's called. A field of slopes. This tells you the direction you are moving in at any given point on the plane. Have you ever seen flow charts for like tides or ocean currents? At any given point, you'll know which direction you're going in. It could be swirling. It's related to each other. If there's a swirl going this way, you might see something related to it going the other way. You know what I mean? You see the similar types of patterns here. We're picking really easy values on this. And this is exactly, they ask you this over and over and over again, fill in this slope field. So you're coming up with a little picture here. So let's do the rest. We want dy dx to be positive. So we want dy dx to be greater than. So what is dy dx? Sorry. Times y minus 1. We want that to be greater than 0. Nice. So what's one observation we can make right off the bat? What's one value x definitely can't be? X cannot be equal to, y cannot be equal to 1. If x, but what can x be other than 0? X can be anything other than 0. So x such that x does not equal 0, right? That's the first set. As long as x, oh, I got to write 0. As long as x is not 0, we're okay, right? Now what about y? Y minus 1 has to be larger than 0. So what does y have to be? So here's how you could describe it right there. Y needs to be greater than 1, and x can't be 0. Y needs to be greater than 1, and x can't be 0. But what could you do? You could draw it if you wanted to. What do you have here? There's your x and y axis. Let's say that right there is y equals 1. So you're looking at above this, right? But then x can't be what? X can't be 0. Where's x equaling 0? The y-axis right here. No. There's a hole right there. At any of, and let's look at our picture. Are all those positive? Yeah. Above, you know it's positive up here. It matches our picture, right? Okay, so that would probably be 1 point. Probably be 1 point. So here's the deal. We know that dy dx is equal to what? X squared times what? Y minus 1. That right there is the derivative of the function we are trying to find that passes through the point 0, 3. If you have a derivative and you want to find an equation of that has that derivative, what verb are we going to have to do at some point? We're going to have to integrate at some point. If you're going from a derivative to the original function, you will have to integrate at some point. We can't just integrate that right there because it doesn't really look like something we've integrated before. Why? Can someone tell me what one problem you see or what? Oh, let's move the dx. So what does dy equal? X squared y minus 1 times. That dy is all alone. It's got nothing there except 1. And we really don't like having y attached to dx. So what are we going to do? Divide by what? Divide by what? Divide by 1 minus 1 and get what you just said. So what do we have here? We have 1 over y minus 1 dy is equal to what? Have we changed anything? No, this is all the same. But what can we now do? What can we now do? One word. What can we do? Integrate. We can integrate. Nice. So we are going to integrate. What's the integral on, what's the indefinite integral on the right-hand side? You just literally did this one. What is it? 1/3 x cubed plus what? Plus c. What about on the left? And we'll call this one c1, just for clarity. What about on the left? If having two constants floating out there, you'll usually see something like this. Ln, not Lm. You'll see ln of y minus 1 is equal to 1 over 3 x cubed plus c3. And we could just say c1 minus c2 is equal to c3. Does it really matter? No. We have a constant going along for the ride. Now, this is a solution, but it's not written quite in the right way. What haven't we isolated yet? We haven't isolated something. We're looking for a solution, and it told us what form to put it in. What form does it want it in? Y equals f of x. Is this in the right form yet? No. This is in logarithmic form. We need to put it in. Begins with an e. Exponential form. This is log base e of y minus 1 is equal to 1/3 x cubed plus c3. Remember, c is just a constant. So how do we translate this into exponential form? Exponential form. E to the what? E to the 1/3 x cubed plus c3 is equal to what? Y minus 1. And I'll show you how they clean this up. Remember your exponent rules, everybody? Yeah, you might. Who knows? This is e to the 1/3 x cubed times e to the what? c3. And what can you call this? Just call that c4. That's just a constant, right? c4, yes. So what do we end up with here? Y is equal to, you know what? Let's just make it d. Just to write it, make it easier to write. D times e to the 1/3 x cubed plus what? 1. Are we done yet? No, we're not done yet. Do we know what d is? We don't know what that constant is yet, correct? How do we figure out what the constant is? Must pass through what? Do you remember? Through 0, 3. So you plug in 0 for what? So 3 is equal to d times e to the plus 1, right? Because it's 0 times a third. So 2 is equal to d times 1, so d is equal to 2. So the final answer would be 2e to the 1/3 x cubed plus 1. There it is, right there. That would probably be 5 of the 9 points, if not more, on that free response question. This is called, just so you know what it's called, you can look it up, this is called a separable differential equation. Separable differential equations all have the form dy dx equals something in terms of x, something in terms of y. So there's your point. To write an equation of a line, you need the point and a slope. So what do? You do dy dx when you're at what point? 0, 2. So 1. Why'd you let me write 1, 0 there? Negative 1, 2. Negative 1, 2. So you plug that in, and what do you get? Negative 1 times 2 squared all over. What is that? So it's going to be y minus equals x plus 1. Done. Leave it like that. Don't go any further. Let's try it. What is it? Dy dx is equal to, someone read it to me, dy dx all over what? 2. Okay, so now what do we need to do first? We need to, not isolate, but we need to separate. The dx's need to get attached to the x's, and the dy needs to be attached to the y. So what do we have here? Dy, let's do this, 2 dy is equal to negative xy squared dx. I just like getting rid of the fractions. So what's next? 2 over dy is equal to negative x dx. Nice, is that good? Yeah? So now you need to what? So did you start integrating? You got a negative there. What are you going to get on the right-hand side? Negative 1/2 x squared plus, say 1, sure. What do you get over here? 2 times what? ln? Why ln? Negative y to the what? Negative 1. What? Oh, basic. Come on, guys. Don't get tripped up that easy. Come on. Hold on. This is being cranky. Looking for. Let me check. You need to get it to at least right here. You have to get it to there. Yeah. As long as you got it to here, you get the full credit. This right here, you see all this work we just did? Was that decently hard? Yeah. Was it impossible? No. Do you know how many points this is worth? 6 points. This is 5% of the entire exam right here, kids. Little less. Barely, about 5% of the entire exam is right here. How many problems? You have 45 multiple choice and 6 free response questions. You do, there's 2 types of multiple. You guys can go over this in the first semester? So you guys did slow fields, but you know nothing about the test itself? Okay. Let's work on this. Did I give you this right here? Oh. I did? I thought I did, right? Did I give you this packet? Yeah. The sub did. Oh, okay. So you read this? Who needs this? Okay, kids. To recap. 50% of your raw score comes from the multiple choice. 50% of your raw score comes from the free response. There are 45 multiple choice questions there. Each worth 1. Do you get any points off for getting them wrong? No, nothing at all. You always guess. Yes. Doesn't change a thing. Doesn't make it easier. Doesn't make it harder. It just means you have to guess. No showing work. Doesn't matter. That's 45 points. Out of 108. Ah, but you noticed something there, didn't you? Is 45 half of 108? No. So what do they do? No, they just multiply the number of points you get by what? Okay, kids. The test is out of 108 points. 50% of 108 is 54. How do you turn 45 into 54? Multiply by what? Which is what? 6, 1.2. So here's another way to think about it. Ready? Here's an easy way to think about it. Every multiple choice question is worth 1.2 points. Okay? Is that an easy way to think about it for you? Stop twitching, Patrick. Pay attention. How many free response questions are there? 6. Out of the 45 multiple choice questions, sorry, we need to recap. Go back to this. Out of the 45 multiple choice questions, some of them are calculated and some of them are not calculated. You know how many of these there are? 20 something. Anybody remember? 21. I'm only delaying right now because I'm not 100% sure myself. I'm thinking it's 27 and 18. I think it's 27 and 18. And I think it's 27 non-calculator and 18 calculator. I think. And I think you only get slightly more time on the non-calculator. I'll check that. It's not too important. On the free response, there are 6 of them. Each question is worth 9 points. Each question has at least 2 parts, like A and B, or A, B, C, and D, or A, B, and C, like we just did a couple of them, right? They're each worth 9 points. 4 of them are non-calculator. 2 of them are calculator. You do each section like that. So I think you do multiple choice first and then free response, I think. And I think it goes calculator and non-calculator. So you have 4 sections. You'll take apart, have a break, take apart, have a break, take apart, have a break, take apart. 4 hours total. It'll take you 18 minutes. The time breakdown, I can look that up. I forget the exact time breakdown. It's like 45 minutes, 52 minutes. Yes, you go to lunch after that. Okay, here you go. This is what I'd like you to do right now. Kids, fill in that slope field right there. 2006 Form B, number 6. When did I not give this to you? Okay, yeah, I was right. On the multiple choice, which is section 1, so you do multiple choice first, there's 28 questions that are no calculator, and you have 55 minutes. And then there are 17 questions with a calculator for 50 minutes. And then in part B, oh, look at that, you get to do calculator first. So on the free response, you do 2 free response questions in 30 minutes with a calculator, and then you do 4 free response questions with no calculator in an hour. You guys are in the gym, yes. Whoever's chewing on something, their teeth or candy, stop. Here, I'm putting this in your notes right here, this link. It's about the exam right here, if you want to know about the exam structure. Jason, you don't need a calculator to do basic stuff for your phone, okay? Okay. How are the other parts? The other parts are good? Okay. 1-0 is the point. Third guess is the charm. Okay. So we're starting with dy dx is equal to what? Someone read it to me? Okay, so what's the first thing we need to do if we're going to integrate this? We need to separate. We need to separate the variables, attach the right things to the right places. So what do we end up with? 1 over y minus 1 squared dy is equal to cosine of pi x times. Now what can we do? Now we can integrate. What does the right-hand side become? Careful. Negative 1 over pi sine of, well, is it negative? Because the derivative of sine is, the other way we'd have to. Sine of pi x plus, let's say c1. What about the other side? Oh, you can do this. Negative y minus 1 to the plus. Yeah, so what do you end up with here? You have negative y minus 1 to the negative 1 equals 1 over pi sine of pi x plus some constant. Are we done yet? Why not? We have not isolated, and we don't know what the constant value is. At this point, you would have earned about 4 out of the 6 points, 3 or 4 out of the 6 points. So you need to keep going. So what do you have? Negative 1 over y minus 1 is equal to 1 over pi sine of pi x plus. So what do you end up with? Negative 1 over pi sine of pi x plus is equal to y minus 1. So you can just move this over here, get rid of that and make it. Are we done yet? But we just earned 1 more point because we isolated y. What do we need to solve for now? C3, and what do we know it goes through? 1, 0. When x is 1, y is 0. So we have negative 1 over pi sine of pi plus 1 is equal to 0. So now we just keep going. Okay, we keep going. Nice. So we end up with negative on the other side. It still is positive. So 1 over pi sine of pi. What is sine of pi? 0 plus C3 is equal to 1, right? So what does C3 have to be? 1. Yay! So we almost done? Y is equal to negative 1 over pi sine of pi x plus what? 1. And tell me if it's the same thing. They wrote this. Plus 1. And then, do you know what they did even further? They wrote y is equal to 1 minus pi over. Is this the same thing? Would we have gotten it correct? Yes. This is fine. That would have been fine. Don't worry about total cleanup. Get rid of the obnoxious stuff like minus and negative. Turn it into a positive. But don't spend too much time. Because here's the thing. If you went even further and then got the blue part but then simplified it wrong, you probably wouldn't have gotten that final point. So stop where you know it's correct. Like, leave things in point slope form. Why? Because out of 100 times, 10 times you're going to get it wrong going to slope intercept form. You're going to get some fraction wrong, and you're going to lose a point.